All right, this video is going to be about theoretical and experimental probability. All right, so let's talk about a few things first. We need to learn or review how to display and count all the possible choices. You probably had this last year, but maybe some of you have not had it ever. So we'll take an example. Suppose your school or our school sells t-shirts in two colors, blue and white, two sizes, child or adult, and two fabrics, cotton or polyester. Draw a tree diagram to show all the possible choices. So you simply do, well, the first two choices are blue and white, so list blue and white. And then after that, they can either be child or adult. Then after each of those, they can either be cotton or polyester. So you do that for all the possible choices there. And then you count how many you'd have at the end. It could be blue, child, cotton, or it could be blue, child, polyester. So that right there means two choices. Then you have two more if it was an adult, and similarly for the white. So altogether, we would have 8 possible choices. Okay, or you could use what we call the counting principle. And that says that if there are m ways of making one choice, for example, this would be there's 2 ways of making that first choice. And there are n ways of making another choice. In this case, it would still be 2. Then the m times the n, you would multiply those 2 numbers of choices that you have. And that would give you the number of ways you make one choice and then another choice. So for example, here we have 2 for the first one and 2 for the second, and we have a third, so we still would continue to multiply. It'd be 2 times 2 times 2, which is 8 choices. Okay? All right. Now, there's 2 probabilities that we're going to be studying. The first one is theoretical. Theoretical probability means the probability of an event, that's what that capital P stands for, probability. Probability of an event, of something happening, like a 6 on a dice or 2 even dice rolls or something, equals a number of favorable outcomes, the one you're going for. I want snake eyes or 2 6s or whatever, over all the possible outcomes you could get when you shake 2 dice, for example. Okay, so let's again get some examples. Supposing you want to know what the theoretical probability of tossing 2 tails when you toss 2 coins. So you take 2 coins, just think about it logically. Well, first we're going to draw a tree diagram of all the possible choices. Well, when I toss a coin, I'm either going to get heads or tails. When I toss a second coin, if I toss the first coin as heads, I either have a choice of getting heads or tails on the other coin. And same thing if I toss a tail first. So of all the outcomes, there's 4 outcomes possible. But only one of them has a tail, which is what I want. I want to know what the probability of getting 2 tails is. It's only 1 out of 4, in theory. All right, or we could say 25%, or you could say 0.25 also. It could either be a decimal fraction, a ratio, or a percent. Okay, what's the probability, theoretical probability of tossing 1 head and 1 tail? Doesn't matter what order. Okay, we do have the same list already. So the probability of getting a head or a tail, I should probably put or in there actually, or tail, is you see there's 2 of those solutions. Here's 1 head tail, and here's 1 tail head. And there's 2 of those out of all the 4 possibilities. So that would be 50% or 1/2 or 0.5%, 0.5 or 50%. Okay, third example. If you're playing the lottery, and supposing the lottery is made up of 4 numbers, chosen at random, what's the probability of getting the winning ticket? What's the probability of having 2 winning tickets? Okay, or picking 2 tickets that'll win? Okay. Well, there's the number of outcomes. Well, we're going to use the counting principle this time because I don't want to list 1, 2, 3, 4, 5, and then or 0, 1, 2, 3, and all those and match them all up. That'd take forever. But I know the first one there's 10 choices, 10 digits. The second time there's 10 digits and 10, and then 10 for the fourth one. So so I've got to multiply all those together, which is going to give me 10,000 total possibilities. If I want to pick 1 winning ticket, I have 1 chance out of 10,000, which equals 0.0001, which is 0.01%. So you don't have a lot of chances of getting the winning ticket. Possibility of having a winning ticket with 2 tickets is 2 out of 10,000, which reduces to 1 out of 5,000, which is 0.02%. Okay, so that's theoretical probability. Okay, now we're going to talk about experimental probability. Okay, that's based on an experiment. That's why it's called experiment. That's why it's actually doing the thing, not a theory. Okay, here's the possibilities, blah blah blah. But this is actually what happens when I really do toss those coins. So it's a number of times the event occurs that you're looking for, the desired event, over the number of times the experiment is done. So suppose I want to, after tossing 2 coins 10 times, I want to determine the experimental probability of tossing 2 tails. So I recorded what happened when I tossed 2 coins 10 times, recorded all the events that happened, And out of them, there are the 10, I had 2 that landed tail. So it was 20% I had. Same thing when I did if I did heads, tails, I counted 6 head tails. These are the head tails. This one here, 1, 2, 3, 4, 5, and 6. So 6 out of 10 were head tail, which is 60%. Notice how these do not equal the theoretical probability that we just talked about. And why is that? Okay, think about it. And if you think about it, because we didn't do that many, we only did 10. So if we tried the experiment 200 times or 1,000 times or something, what do you think would happen? Well, we would get closer to the theoretical probability. Okay, and we'll do more of that in class when we talk about this. All right, one last thing I want you to, just some more information I want you to get down. You're going to learn now, you're going to be hearing about relative frequency. And relative frequency simply is, it shows how frequently or how often a given outcome actually shows up in an experiment. Well, that sounds a lot like experimental probability, which is exactly what it is. The relative frequency is really another way of saying experimental probability of an event. It can be written as a ratio, decimal, percent, which we already illustrated. The relative frequency becomes an estimate of the probability of an event, okay? The more trials you run, the closer to the experimental probability is going to equal the theoretical probability. All right, and the relative frequency or the experimental probability can be used to predict, okay, the theoretical probability. And as you get more and more into statistics, you'll see that play out. All right, take good notes. We'll have a lot of fun tomorrow.